Hello, everybody. Can you hear me? Yes, so we hope you are having a great day at PyData. You have seen a lot of great presentation. We have a new great presentation from Denis and Agustin from Rabobank. So yeah, let's cheer on them. Let's give them a round of applause.
Well, welcome everyone. I hope that the afternoon deep has passed now and you are full of energy to listen to another presentation. And to start, I want to ask if anyone here knows about the Theseus paradox. Please raise their hand. Okay, I see some philosophy enthusiasts in this room. Theseus is the son of the king of Athens. He was the one who fought against the Minotaur. And by defeating the Minotaur, he gained the independence from Crete and also saved some children. After defeating the Minotaur, he came back to Athens and he with his boat. And the people of Athens were very happy about it. And the way that they do is they celebrate this independence every year by going around with this boat. You can imagine that after some time, the boat needs to be repaired, like some parts of the boat needs to be replaced. And the more time it passes, the more parts need to be replaced. Until at a certain moment, all the parts of the boat, of the original boat, had to be replaced by new parts. The paradox states, okay, is this still the ship of Theseus? In my humble opinion, is not. But if it's not the ship of Theseus, when does it stop to being the ship of Theseus? My name is Agustin Iniguez, as introduced. I'm a data scientist at Rabobank. I've been working there for 3 years, bridging the gap between engineering and data science. And here is Denis Gaitan, my colleague, with 12 years of experience in software engineer, leveraging this experience in the data science world. A fun fact about me is that I did my PhD in origami. And a fun fact about my colleague is he likes coffee, but not only coffee, he likes cappuccinos, and he drinks it at any moment in the day. So if there's any Italians in this room, you can fight with him afterwards. Yeah. So, of course, Theseus paradox is a complex philosophical question. And we're not here about talking about philosophy, but talking about machine learning models, AI models. So I will try to draw a similitude between that paradox and machine learning models. For that, let's point out the key elements of the paradox. First, of course, is Theseus ship. That's the main element. The other one is the annual celebration, so they go with the ship around. And the last one, of course, are the boat repairs, like the changing of the boat. If we do this, well, the Theseus ship is the model. It can be a machine learning model, AI model, any kind of algorithm that goes, any kind of algorithm that processes data. The annual celebration, it means that it's a continuous usage of the model. It's used in production. And the boat repairs are changes that the boat has, changes that the model has. It might come from the CI/CD way of working. It might be just retraining new features, repairing bugs. With this similitude, we can ask, okay, how do we know that the model still does what it needs to do? Before we answer that question, we need to answer, well, what does the model actually needs to do? And for that, well, we have the MLOps lifecycle. I'm pretty sure you're all familiar with this infinity loop. I see some nodding. I will go through it anyways, because I think it's important to refresh our minds. Of course, you start with the planning. This is where you have a problem, you need a solution. You gather the requirements, the business requirements, and you plan. Here is where the soul of the model is being created. Then you code it, you build it, you basically create a package of the model, and this is where the body of the model is being created. After that, you test it. You can unit test it, but importantly, you also do functional tests. So you test against the plan that you have. You actually test that it should do what it should, the model should do what it's meant to be done. When it actually does, you release it, and you deploy it. Congratulations, your model is in production. People are using it, but it doesn't stop there. You still need to make sure that you operate it, it stays in production, and you monitor. And that's where we are going to focus, on the monitoring part. You can monitor very different kind of things. You can monitor metrics, you can functional, non-functional, and we are going to talk about monitoring changes, like data drift, but more specifically, model drift, because model drift is a thing that it's in your hands. If you see the model drifting, you can always do something about it. And yeah, so we are going to present a solution for this monitoring drift, for monitoring model drift. And as anything in the corporate business, like don't forget we work for Rabobank, you need to first get some requirements. So what does this monitoring solution needs to look like? Well, we have three main requirements. The first one is that it has it needs to be automatic measure of these changes. So it's a standardized way of measuring, of monitoring the changes. Second, it needs to be integrated in the CI/CD process. So that means that it's not just an ad hoc monitoring, but it is run every time that we deploy to production. Last is separation of concerns. If you have a model that has a lot of dependencies, you want to measure the changes of just your model and not the changes of other models. So you need to separate these concerns. Now that we have a little bit of the vision, the requirements, let's talk about the model. Our model that we use is called TICS. TICS stands for Transaction Income and Expenses. And it creates automatic reports where the reports is an overview of recurrent income and expenses of a person or a business. The way that we do it is by taking transactions. It can be internal transactions from the bank, from Rabobank, or external transactions from other banks. And we add to these transactions the category and the periodicity, how frequent these transactions are. And from these two parts, we create a report. Important to mention is that the category and periodicity that adds the frequency of the transactions are two different models separated from our model. So there are our dependencies. And that's why one of our requirements is to separate the concerns. Now that we have the model, and before we start building the whole solution, I'm going to present a framework that explains a little bit the concept behind our measurement of model drift. To start, let's bring out a timeline. This is the release timeline of TICS, our model. So we start with a version, and then we release. We do a couple of releases. These releases, of course, as I mentioned, they can be fixes of bugs, new features, retraining. It can be whatever, just a new version of the model. As I told you, we have dependencies, so we also add the dependencies, the category and periodicity dependencies. And you can see that they don't align with us. And of course they don't align because they are independent from us. It's not the same team, it's a completely different team. It can be even a completely part of the bank, a completely different part of the bank. And then, so to measure the model changes, we create a thing called a state. A state is defined by the reports, so TICS creates reports. are reports based on a specific version of ticks, category periodicity, and a specific data set. The data set, well, let's add also a data set. And as you can see, it aligns perfectly with the versions of ticks because, well, it's just a sample that we create. And now we can create the different states, state 1, 2, 3, and 4. And then we can just start comparing these two states. However, if you see, when we compare state 1 and state 2, it changes everything. It changes not only the ticks version, but also the category periodicity and even the data set. And this is not according to the requirements that we have. We wanted to separate the concerns. So let's bring back all these timelines and put the states. And as you can see, I slightly shifted the creation of the states. And there's a reason of that, because we are going to create two other draft states. These draft states, one is just before releasing, and the other one is just after releasing. And the one just before releasing, it will update the dependencies. And the other one will update the ticks version, but still use the old data set. And now, as you can see, it is quite clear that if we compare these two versions, these two states, the only thing that changes is the version of ticks. That means if we see any changes on the reports, it has to come from the changes of the version of ticks. So this is a little bit of the background. This is a little bit of the framework that we used. For the actual implementation, I want to invite my colleague, Denis. He will talk about the actual implementation.
Thank you, Agustin, for sharing our plan and for introducing the framework. Of course, the next step is to actually see how it is implemented. But before going there, I would like to ask you a question. Who of you is confident on deploying into production on Fridays? Some people, nice, nice. Who of you would rather postpone it for next Monday? Okay. I see going safe. And the last one. Who of you would rather not care which day of week is, but rather have confidence in what changes are going into production? Okay. Really nice. So let's see how model changes framework is integrated into deployment into production and how it fits into the whole CI/CD process. We use Azure DevOps for continuous integration and deployment. Azure DevOps is a suite of development tools and services that helps us to code, build, test, and release our changes. And of course, for continuous integration, the first step is to build our model. It can be anything. In our case, the business core logic is written in Python, so then at the end of the day, it's a Python package. It is exposed through REST API, and other consumers can use our services. And of course, just before going to production, what's happening? As a responsible engineer, of course, you would first have a manual approval. You want to have a conscious decision when you deploy something into production. I can imagine some of you are more keen into continuous delivery, shipping all the time, as I think Google does it. Personally, I think it's still valuable to have a human in the loop and then decide when you want to go further. And after we decided, okay, we want to ship our changes into production, what happens next is we run our model changes procedure. Actually, trigger would be a better word to use because we make use of Databricks workspace or jobs. As you might know, Microsoft has a hobby in changing their names of the services pretty often, I would say. Probably they have a KPI on how much time they rename stuff. So we trigger a Databricks job, which will create the draft states, we'll compare them and create the metrics, and the results will be written into a Databricks Hive metastore. And of course, the next step, we want to visualize those results and assess the model changes, the model drift, and then decide, is it something that we are expecting or not? Is it within the boundaries, within the acceptable ranges? And then decide, is it a go or no-go moment? And because we work at Rabobank, we are really conservative. We like so much to be compliant. Of course, we have another manual approval. We really have to make sure that we want to go into production. And of course, the last step is to deploy your changes or our changes into production. So this is an overview of the process and how it fits into the picture. So let's deep dive a bit into two main components of this framework. So run model changes, as I said earlier, we use Databricks, Databricks job, to orchestrate all the creation of the results. Nothing fancy. We have 5 tasks, which does the job. The first 4 are pairs of 2. Why 2? Well, we track 2 types of changes. The first one is called single change. So we compare the current production version against the new version that we want to release, and cumulative changes. We compare the new version that we want to release against an earliest production version within the sliding window of 3 months. 3 months is in our case. I can imagine there could be different requirements for different teams. So with cumulative changes, of course, we can make sure that if we skip the run, or because sometimes you don't want to run model changes for each minor change, like adding some logging or some minor changes in the infrastructure. So then cumulative changes will catch changes for a broader spectrum of time. And the last task is to compare those draft states that we created, and we have the metrics that are written, like I said, Databricks Hive metastore. All these tasks are written in Python, since we are in the data department. We love Python. And it's separated from the model logic. So it's a different repo, different code base, and then that also ensures separation of concerns. So what we measure, what we monitor is separated from the logic itself. Let's move on to the second part, which is visualizing the results, right? So we want to assess, are there any changes, and to make a decision of go or not go. We use Power BI. It's another Microsoft tool to visualize the results. It's a business analytic tool that helps us to get insights into the data by the means of dashboarding and reporting. Again, nothing fancy. It's a simple dashboard. What we have here is on the left side is some metadata. On the top is the type of change that we are seeing, the results. In this case, it's single. On the bottom or below, we have some metadata of the run, like creation date time, pipeline ID, and a percentage of the model drift, how the output changed. And we use a color scheme for it, just to have a quick reaction, right? Of course, you always want to see green. The green means, of course, no changes, 0, so probably you're good to go. Yellow would mean there are some changes, but they are within the accepted boundaries, within the accepted range. And red, well, you're in trouble. Well, actually, it's not really the case. Red means that there are changes, they are outside your boundaries, accepted range, most probably it's good to check what's happening, but it might be that something that you're expecting. In our case, we would need some additional approvals to go with this change. On the right side of the screen, you have 4 areas, 4 squares. Those are the types of changes that we are tracking. And 3 of them are the ones that we are expecting our model to influence. It's something that, if it happens, we want to be in that spectrum. In this case, it's category name, category group, and user rule change. And the 4th one, any change, it's actually a pretty important one. We still want to make sure that nothing changed in the output. So we are tracking everything, even the one that we are not expecting. And we will see in a second why that part is important. And this brings me to the final part of the presentation, which is sharing the results that we had. Well, of course, the first time when we integrated the framework into our project, we created the state, the time 0, right? And then at some point, we had to also have the first run to compare the T1 against the T0. At that, I don't remember exactly what changes we had, but there were no changes in the core business core logic. So we were expecting the green light, right? The 0. But as you imagine, nothing goes as you expect. So to our surprise, there were some changes reported in the any change category. So of course, the first instinct, yeah, probably we implemented something wrong in our framework, and we have to make some small adjustments. But actually, the results were legit. So we checked a bit. Well, everything was fine. So indeed, there was something that was changing. We had a closer look, and we realized that the output of our model was influenced by the output of one of our dependencies. So we reached out to the team. They conducted a research. And the problem was, well, it's pretty simple, right? For the same set of input, you have different output. Everything stays the same, only the output changes. So it looks strange. And that's what we learned. First, be careful when comparing floating point numbers, especially considering that the addition is not associative in this case. It has something to do with how the data are stored on the hardware level. I'll not go into detail. I'm not that proficient in that, but I know the cause. And this, in combination with having a group by statement without an order by, actually creates a non-deterministic behavior. In our case, luckily, it was a corner case, but still, it's something that we didn't catch with traditional testing, right? With unit testing, functional testing. And this showcased, actually, from the day one, that it's essential to monitor your changes, your model. Well, either we reached out to you and made a statement, or we bored you, that's also fine. But I want you to stick with 3 things out of this presentation. Whatever happened before, you can stick to these 3. First, always be on top of your changes, of your model drift. Ensure that you are in control and you have a stable model in production. Second, automate. I'm in love in automation. I'll automate whatever is possible. At the same time, leaving the key essential points to humans. Leave whatever you want to actually contribute to that part and don't bother of things that can be automated. And third, investigate. Investigate always the results, even if they look small. In our case, it was below 1%. I think it's a good insight. If you have an intuition, just go for it and check what's happening there. You think that we learned from the first time? Well, no. On one of the further runs, we also had a change, but in that, at that time in the cumulative changes. So we saw a deviation, and we thought, yeah, probably it's fine. We didn't look into, well, it was a pretty serious bug. Luckily, we caught it on time, just a day after. But the rule still stands, investigate always. Even if you think that, yeah, 0.01% is nothing, it's pretty important. As Winston Churchill was saying, to improve is to change. To be perfect is to change often. Thank you for your attention. Thank you for listening and surviving this session.
Amazing. I think some of those bugs needed a lot of cappuccino to be solved. But,
Yes.
Thank you. Do we have some questions from the audience? Yeah, here.
So do you trigger this process even when an external dependency changes? So for example, if you go from T0 to T1 is one thing, but if T0 stays T0, but C0 goes to C1, do you still trigger this change because that is not your ownership, but someone else has changed and it could change the outcome of your model, for example?
So I don't think we will trigger at that moment because it's not in our power to do something about it. I think there is also, I mean, it is important to keep in line the dependencies and to track if there's changes on the dependencies. For that, for example, we have set a set of requirements for our dependencies, and I mean, now in the close future, we will start measuring these requirements, and when they don't fulfill their requirements, we can always go back to them and say, hey, you're changing, and this will affect ours. But measuring these model changes when a dependency is changing, I don't know if it will give us much more insights.
I would encourage that team that deploys the changes to monitor on their side.
Yeah.
And then more people are in control, and those edge cases should just be a real exception.
Yeah, so I mean, an example is that if I'm using scikit-learn from 3 versions back and I do some changes now, 3 months later, I see that a lot of things have changed, but nothing has changed on my end. There is something that scikit-learn is doing weirdly now. Yeah. So it becomes very difficult to narrow it down if I don't save the state of each thing, but also saving the state is not in our hands. I was wondering how you handle that.
No, we only run when we do some changes. Well, in this case, for example, if we upgrade one of the libraries, then yeah, we will decide, was it a good moment to do it or not? If there are too many changes that we cannot understand, then most probably we'll delay or analyze more in depth what's happening.
Yeah.
Any other questions? Hello. This is on more practical side, but what metrics do you learn to actually track and plot on these dashboards for in your domain? Because in practice, I had mixed experience with some of those. Question number 1. And number 2, sometimes there are changes that you expect, like seasonality. Many businesses are seasonal, and so they will be reflected, but you expect them. Do you somehow tackle that case? Thank you.
Yeah, to answer the first question, so what metrics do we use, do we actually measure? Well, in the bank, we have a very clear way of putting models into production. We have a model documentation and model validation, and there we have to define very clear metrics that we have to measure in order to define the model. So we use those metrics. In this particular case, it's a complex structure. The report is a complex structure, and we just basically compare report to each other, with the same data set, we compare the results and see the changes and see whatever it changes. So if the category of a transaction changes from, let's say, groceries to salary, that will we consider a change, and then we just aggregate on that level. I don't know if that answers your question.
I was thinking more of measures like Kullback library divergence or population index shift.
the data set, we ensure that we cover the most of the input, right? The data set was actually the input of the model. So the sample that we create, we take a sample from all our consumers, the examples, the input data from their side, so then we cover the most of the population that uses our model. And from the output, yeah, we know exactly what is in our control. Like that category name is just a mapping, is just a name, but we know that we can influence, we change. So then if we do change the name, we are expecting to see some changes. If not, then maybe something weird is happening there. That's, I think you had also the second question, but I don't remember now exactly that.
Yeah, expected seasonality or other expected changes.
Yeah, because we take the sample and we use the same sample to score before and after data sample. Then I don't expect that the seasonality will affect the results. So we always score with the same data sample.
The sample is created through time, so
yeah.
Each time we will cover different parts of the, well, months, days, depends.
But we can talk later.
If we didn't answer, yeah, please reach out.
Hi, thank you for your question, or for your talk. I had a question about the data versioning, actually, because I'm not sure if it's applicable to your model, but if you're making a machine learning model, it's quite often that features are removed from the model. Would that mean that you have to keep it in the data to be backwards compatible, to keep, like, maintain the cumulative changes of your model?
Well, if I understand correctly, actually it's our dependencies will care more about that because they are responsible for the categorization and sequence detection. In our case, yeah, like the mappings, the names, we do change, and we have backwards compatibility at some point, and then we do the cleanup. But I don't think we have that pain of data versioning, I would say. Well, only the mappings, the names with some IDs.
And for the input data from the sample data that we have, we don't take a very big data sample, so we can just save every time the sample, and that's enough for us.
Any other questions?
Hi. One question: do you use like business outcomes in any way in evaluating model changes, data drift? Is business outcome in any way related in the framework?
Yes, I want to say yes.
I was thinking about the user rules.
Yeah, exactly. So I think part of, like, most of the things that we measure, like the expected changes, are mostly from business decisions. So we have user rules that are just depending on the user of our model. It can change the result. And those are, well, we measure those changes due to these user rules. So each end user can change their user rules. But for example, we also have category names and category group names. You can imagine that category group names are grouping of different categories. And if it suddenly changes, like we describe it as salary on one version, but on the next version we describe it as grocery, it will be interpreted in a very different way. The report will be interpreted in a very different way. And that's also why it's important to measure these changes, because then we ensure that the reports for the business are kept in, well, they are interpreted in the correct way.
Maybe to add to that, if I understand correctly the question, like that user rule, and I was saying about that bug, it actually, our end user predicted some changes that should happen, right? They did an analysis, they created those user rules, they had a number in mind. We also ran the model changes, after applying this change, and we saw a percentage, only ignoring those cumulative changes which should have triggered us. But we were both validating from our side what we see, and also from the business side, well, from our stakeholder side, the expectations of how much the output will change by applying this change, by this user rule. I don't know if it answers, but that's what I understand as if the business output is considered or not.
Amazing. Thank you so much, guys. Let's give them a last round of applause.